Hey, I'm ready.
Okay, so I'd like to welcome to everybody to the first IRWA Chapter 88 virtual event. It's been 4 years in the making, and it's a pretty good milestone. We're the first chapter in a long time to be added to the IRWA. I've heard positive comments across the other chapters how active we are. We're as active as some of the most active bigger chapters. So that's a kudos to everybody that's participated. And I think we've got a couple of new people on here as well today. So welcome today. So at this time, I'm going to turn it over to Jim Garner, who is my brother. So that's why we're both very good looking guys. Um, Jim and I have been in business multiple times over the years, and some successful, some not as successful. So, you learn from your failures. So at this time, I'm going to go and turn everything over to Jim, and please ask your questions in the chat, and we'll get them answered at the end. So at this time, Jim, it's all yours.
Okay, can everybody see my screen offering a drone UAV service to clients?
Yes.
John, okay, thanks, Johnny. This will be interesting, and I think probably the best way to dive into this. We had to pick a title for the content that we were going to go over today, and I thought that it was appropriate because at Mott MacDonald, where I'm a W-2 employee, and I have been working to stand up their UAV program, we go from week to week, and you never know what's coming around the corner. And that is, as far as drones go, that is typically because it is a new technology. So anybody that's worked with a new technology, and typically that's where I found myself at the meshes of where people and new technology and data come together. Whenever you have a new technology, it's oftentimes bleeding edge. It's certainly cutting edge, and you can use that to your advantage in business, or you can end up being cut by it. And so I wanted to present some information about drones, and that's also known as UAVs. If anybody didn't understand what that acronym was, that stands for Unmanned Aerial Vehicle. And I only deal with the aerial side of things. There are amphibious robotic vehicles that take pictures in sonar and things like that. So I'll just be concentrating on the aerial side of things. But I became interested in this after becoming a pilot and seeing the new technology. I was working on a pipeline right-of-way job over in Columbus, Ohio. And it seemed to me, based on us trying to find a better route, many people here, and especially associated with the IRWA, that's often what we're doing, is we're looking for a right-of-way, a way that we can get something through. And we were running into a lot of problems. One problem was associated with going around an active airport. Another problem was going through national and metro parks. And obviously there were plenty of challenges there. But one of the things that we didn't have was a really good representation of what that route would look like overall. I mean, in the real world, we were looking for staging areas, and we were looking for routes, and we were looking for areas of least resistance. And in particular with the staging areas, one of the things that we realized was what we thought was a staging area months before was now already occupied by somebody else. And just up the road, an area that was going to be right beside the right-of-way and the route that we were going to use for this transmission line, there was a brand new site available for pipeline location and staging area and things like that we weren't aware of. And I thought one of the things that would really lend to this project and help us stay on timeline, because in these larger projects, especially in transmission line projects for natural gas, it's not busting the timeline. So it's more about time and finishing on time according to the schedule than it is oftentimes about how much money you're spending to finish the project. So I saw this opportunity where if we had a drone representation of real-time, high-resolution overview of the area that we were trying to get through, it would be very helpful for project management to consider the best approach for this project. And indeed, that turned out to be true. Now, at this time, there wasn't as many regulations in place. Part 107 wasn't a real thing at the time. It was just being talked about. And the FAA was watching very closely as more and more drones and hobbyists were coming around and flying their drones and getting in trouble and getting shot out of the sky. All of these things played a central part in how I got into this industry, and I'm still involved in it. So when I titled this content of UAV service for your clients, it was really a two-pronged approach, and I want to make sure that's clear up front, and then I'll give you a synopsis of where we're going to go and the content we'll cover today. The two-pronged approach was this. First of all, Mott MacDonald does offer UAV services for companies that want to get real-time video or photographic correct information about an area that you have a project going on. So Mott MacDonald does offer those services. And as well, smaller companies, or if you're in business with yourself and you want to have this as a side item or something that you can offer to your clients, I have my own company called Ground Scouts that has been offering training and showing companies how to do that over the last several years. So either way, I may be able to help you, and certainly through Johnny and the IRWA and what he's put together and worked with here with all of you folks. I love being involved in the technology, but I also like helping coworkers and people who are trying to go forward with business. So with that said, my plan for today is to go through an idea of how you might set something up, what are some of the pitfalls, what are some of the benefits. I've got video, I've got photos, I've got three-dimensional access in viewers. Thankfully, that was just given to me a few minutes ago because my account was locked out a couple of hours ago when I was getting ready to just finalize the presentation. But what you'll come to find is a technology that is just being birthed. There are a lot of pitfalls because of that, so you've got to work your way through the technology. But once you get past that speed bump, so to speak, you'll see some of the benefits of having really a bird's eye view of what you're looking at on the ground, as well as having new tools to measure and to deduce what areas of interest you want to concentrate on for a project that you're working on. We can go a little bit into regulations and other things. And I've asked Johnny to have everybody hold the questions until later on in the presentation, because I think that might be the main focus of this content, because I'm going to bring to light a lot of different things, and I think that will spur a lot of questions, and I'll try to answer your questions as quickly as possible. So to make sure that I don't bore anybody, I think I've only got 8 slides. I'll talk to each one just a little bit, and that will introduce you to some information, and then we can get into the question and answer session and see where that takes us. So next slide.
Real quick, somebody's got their mic on. If you could turn your mic off. Sounds like you have potato chips. Sounds delicious, but if you could turn off your mic, I'd appreciate it.
All right, the areas of service for new technology. For drones in particular, you really have to consider what is your mission. So whenever we're dealing with anything aerial or aviation related, we talk about the mission. There are different airplanes for different types of flights. And in the case of drones, there are different drones for different types of flights. There's also different sensors. 2 different pieces to a physical drone flight. The first one is the platform, and that is the quadcopter or the fixed wing drone. big, small? How much flight time do you have based on the battery? How many acres do you need to cover? Is it all in one line, like in a corridor, like most of us are used to, because we're perhaps dealing with power poles or natural gas transmission lines where there's a corridor that we're trying to map or get permission to be on, survey. All of these things are served by drones, but there's many different types of drones that we can use to put up in the air and many different sensors. The sensors typically that we work with are photographic sensors, meaning that it takes a picture, an RGB picture, and that's the RGB sensor. We can use LiDAR that a lot of people are becoming familiar with. This is a process where we really get a very accurate idea of what the Earth looks like underneath the canopy cover of the trees. Buildings and other things are removed from the surface of the Earth so that we can use that product for civil engineering and see the topography of the Earth. I've got one example where we were looking at waterfall and how a natural gas station was just being kind of flooded. In fact, we've got two of those where UAVs were a great solution instead of sending a whole ground crew out just to survey points, hundreds of points across the entire station. It made more sense to put a drone up and get just some accuracy points to make sure that we rectified that information correctly. So the list that I put down here is just a basic list. Do you want to use a drone to show a video overview? Do you want some site references where you just want to see how big the ditch is coming off the hard surface road onto a valve site? Do you want to do mapping where you're going to end up with a very accurate 3D rendition of feet and inches down to the centimeter and sub-centimeter? Do you want to do inspections where there's an area that's very difficult to get to, whether it be a tower or take a look at how much debris is covering a right-of-way that's supposed to be cleaned up? I think some people are familiar with that. Or do you want to do some monitoring or represent something as built after a project is pretty much completed or while construction is going on? These things are very important to consider before you put a drone in the air, and different drones are much better at different types of missions, so you take that into consideration. So before we go any further, we're just on slide 2. Like I said, I think I've got about 8 slides. I've got 10 total just because I have some reference material, but I want to show you some things that come from a UAV program. First, let's go to some of the planning and what we come back with. Johnny, give me some feedback. Can you see my screen still since I've switched screens?
Yes, I can.
Okay. So this is a KMZ. Most people are familiar with Google Earth in some form or fashion. This is a great planning tool, but oftentimes people are using the Google Earth overlay. So you can see some of that here on the side where we've got pictures of mountainous tree cover. Something that happened here not too recently was we had a slip that happened over top of a pipeline, and we've got to do some mitigation very quickly. Well, the current Google Earth mapping of that area wasn't very good. In fact, we were very concerned that things had moved, that staging areas, if we were going to do an HDD to get through the slip, that areas that we thought were available for pipe laydown and other things might not still be available, or new areas might be available. Also, from a safety concern, when you've got a slip, you don't want personnel out there where they might be in danger on foot. So flying a drone over that type of area and getting a bird's eye view of what's really going on is helpful. What we're able to do is take that high resolution imagery and overlay it on top of Google Earth. So you still have the same control and capability of Google Earth. We can zoom in, we can see different things, but now, as you can see, we've got a very high resolution imagery from the drone that was flown. And here we see you can actually see the pipeline in here going across. You can see a lot of the debris that has come down. It was in the road and was since moved off. And it also, on a drone flight not too long ago where we were mapping out a similar slip to this, which was much bigger, what would have taken place previously is a survey crew would go out and take a lot of shots around the area to see what the lay of the terrain was and to start their mitigation procedure to deal with a slip of earth that had come down. But because we're able to put a drone up and fly quite a bit more than what a typical survey crew would be able to go out and get, we were able to find out that there was actually a slip within a slip. And this saved, I would guess, millions of dollars, because the original smaller slip would have been fixed and then it would have deteriorated with the larger slip shortly after. So this new technology from drones is actually opening up a world that we hadn't considered before, that we can go outside of the boundaries of what we typically fly. And I probably should add here, when we're talking about outside of the boundaries, aside from a safer way of looking at survey information and representing what an area looks like before we even get on site for the project managers to decide what they're going to do before they get there, boundaries are an important part of what we can cover as far as UAVs go. And I'm sorry I use that term. Sometimes I say drone, sometimes I say UAV. There's so many different acronyms that the FAA has applied to drones, it gets confusing. So if I confuse anybody, I'm sorry. We'll try to fix that up at the end of the call. But in speaking about boundaries, I had a recent UAV flight where a pipeline was mapped out and everything was ready to go. And the one area that we could not get survey on was across an active railroad. Now, as people who are familiar with right-of-way work, you probably are familiar with the kind of challenges that are just ever present whenever you're dealing with a railroad. There's a lot of power there, but there's also usually quite a bit of delay as you go through the logistical process of making sure forms are filled out, the proper paperwork is in the proper hands, and then you think that you've done it the correct way, but you come to find out that you were supposed to be talking to somebody else and doing something else, and everything gets delayed. And it's not usually by hours or days, it's usually by weeks and even months. And I've experienced this myself. I know Johnny has, and many other, I'm sure, here on the call. So we had right away that had been surveyed all the way through the route that the pipeline was taking, except for what was going to be covered for an HDD underneath a railroad. And oddly enough, even though we couldn't get permission to be on the railroad to do the survey, because you've got to have a flagman and many other things, we were able to get permission to fly that with a UAV. So we took accurate shots. I think we took 7 shots total, 3 on one side of the railroad and 4 on the other side of the railroad. And we put those together with the aerial footage that we got, and we were able to create a 3-dimensional terrain mapping of that railroad bed and even the curvature of the railroad. So it was an impressive project that gained great results and actually saved our timeline. So going back to the basics, there's a lot of different reasons why you would use drone coverage. This is a great example when we look at Google Earth, an overview. Let me take you to another one. I talked about some water issues. This is a great example of that. This is down in Kentucky, and a couple things that I'll point out from this presentation is Just the way that we've got to plan a UAV flight. This is a station, a natural gas station that we have here at the foot of the hill, and we had LiDAR data from public sources that was showing the water as it was coming down off of this hill. But until we got out there with the drone and flew it, we really didn't have much of an idea of where things were happening. So this shows you two things. It shows you, first off, the complexity of doing a good UAV flight where you're going to obtain a lot of the visual information as well as the accuracy from survey. And it also showed us that when we were coming down off of this hill, let me get rid of some of this overlay stuff. Excuse me. There we go. So when we had water coming down off of this hill and going into the station, it was creating a lot of water here. We thought that there was a problem with this end of the station where there was drainage, and there's other drainage over here. But what may have been happening is all of the water from the hill was coming down and sitting on this side of the road. And because the road was not draining properly, the water was coming over the road and going into the station. I'll show you an example of that with, let's see, switching screens on everybody here for a second.
Hey, Jim.
Yes.
This is Michael Lopez. Sorry, but can you just tell people what LiDAR is? I mean, just so that they all know.
Yeah, I like to keep these things as simple as possible, but LiDAR is basically shooting pulses down at the ground very, very quickly. It happens so fast that as the drone is moving, we oftentimes get a shot of light that goes down around a leaf or canopy coverage of trees, hits the ground, and then bounces back several times. And the sensor reads that bounce back of information and can determine whether or not there's vegetation, we've hit the ground, we've hit a water source, and really gets past some of the things like, I'm hoping that you're seeing my screen right now. We've got a lot of vegetation in this area, as you can see, and with that vegetation comes a lot of problems for the typical drone flight, which is photogrammetry, where we're just taking visual images with a camera, where we stitch hundreds, if not thousands, of pictures together and then come up with a three-dimensional representation of what is out there in the field. With LiDAR, it's much more expensive, but we can fly a lot higher above the ground, so we avoid the tree limbs and things like that. And we also get an exceptionally accurate representation of what the ground itself looks like, which is typically the most important thing, especially when we're dealing with any kind of survey, with civil engineering projects. Did that help answer your question?
Yeah, but LiDAR is imagery taken by actual planes that capture images.
The LiDAR that thank you for that. The LiDAR that I was talking about in the previous discussion, and let's see, this was over here on this. So on this mountainous hill here, this area right here, I hope you can see my mouse moving. This was developed by public LiDAR that was taken by aircraft, a manned aircraft. And that often is the case with LiDAR that's available in the public sector. But oftentimes that LiDAR product, because it was produced by a state or sometimes a county, but usually some sort of entity that's interested in seeing water flow and topography of an area. They will pay for that work to be done, and it's done by manned flight, but it will not be to the survey grade accuracies that would be needed for something like rebuilding a natural gas pipeline station. For something like that, we would often put a LiDAR unit, which is the same type of unit, onto a drone, and we would fly that drone at about 300 feet. Now, in the case of this project here, a manned flight would not be able to get anywhere near that short of an elevation because there's such a mountainous area. So we would get a lot better return, a lot better what's called a point cloud. That's millions upon millions of points of data in X and Y and elevation in Z. So LiDAR is a payload that is used on manned flight for larger areas, and it's also used on UAVs. All right, talking about that water image. So when we took to the sky with our drone, and we were able to fly quite a bit lower. This is using photogrammetry, not LiDAR. We were able to drill down into some of the basics that we couldn't see by just looking over the map. For instance, what is the turn of the road? What is the lean of the road? How much water would need to be piled up here in this ditch on this side of the road before it just comes over the embankment down into the station? And I suppose because I'm doing a video presentation, my connection is not fast enough to update this. We see globs of information here, and at times it'll look better and worse. You can see the resolution here is good, but down here I've just got shapes. This again falls back to this being a new technology, and so you've got to, there we go, this popped into a better visual. So we can see, come on, we can see even the tines of this forklift inside the station, and we can get to even closer photorealistic information of any site that we take with a UAV. So not to go too far into detail here, I just wanted to show everybody a little bit of the representation of some of the things that you can get back from UAVs while we're going through these screens, these shots. Let me switch back here real quick. So what is your mission? There's a lot of different ones that you can use. We've done some video flights that I can bring back and show you here, show you a little bit of video and talk to you about some of the difficulties and some of the things that really are lent to showing the reality on the ground from a UAV perspective. Video flight, for instance, my personal company has done some litigation flights. One in particular was to show how a right-of-way that may or may not have been where it was supposed to be might have taken away from the value of the farmland that it was on. And so the litigation case was based on how difficult of a terrain it would be to use for farming. So our job, our directive was take a UAV flight, show us a video representation of why this farmer should not be compensated for millions upon millions of dollars because we may be 10 foot off of our right-of-way in this section at the top of this hill. It sounded like a pretty reasonable mission for us in the beginning, but honestly, it's very difficult to show the topography of property from a video. We would have done much better with a LiDAR shot or with a mapping shot in 3D to move things around and show the jury what kind of topography was at risk for this farmer. We accomplished what we set out to do, but it was still pretty difficult to accomplish with a video as opposed to mapping. So again, consider what your mission is. Are you trying to map something, inspect something, show video, or look for areas of opportunity for laydown yards or better routes for a right-of-way? I titled this Joe Schmuckatelli and the FAA. Part of that comes from my Marine Corps background, but part of it has to do with the FAA. The Federal Aviation Administration, they control for the United States public, they control anything that is in the air, 1 inch above the ground. I mean, you could get really detailed and say, well, it's a half of an inch. And in different areas, it's different elevations. But for the most part, if you jump up in your front yard, you could very well be in what's known as controlled airspace. That means that the FAA is going to determine exactly what can and should not happen in that area. Most of the time, it's not a problem, but some of the times it is. And especially if you're working really hard to get a right-of-way through, let's say, a portion of a city, that typically is going to be in some sort of controlled airspace because you've got a larger airport around the area. There is a difference between somebody that is flying a drone as a hobby versus commercial use. And that becomes really important, especially out on the right-of-ways that I've been working on in the past several years. I've seen a lot of people who were there just as a worker on the right-of-way. And the project manager would ask said worker, hey, I thought you had a drone. Can't you just stick your drone up in the air and give me a shot of this so I can have a representation of where we are in the work? That sounds like a great idea, and it is a great idea, to be honest with you. But as far as the regulations that cover that sort of thing, that is not something that can happen. And it has very little to do with whether or not there's compensation that changes hands for that drone flight. One is a hobby, and that typically would be something like I've described here. Joe is on a vacation and he wants a picture of the campfire with his girlfriend or whatever. That's a hobby type of flight. And then the other type of flight is where there is a commercial entity involved. They're trying to do a specific type of work, and the drone's being used to support or to provide a service or a product back on that project. And if that's the case, it falls into a commercial flight, which has to be handled by a Part 107 pilot. And you know, we can get into the weeds of the FAA and what they say has to happen or what can happen without the FAA being involved. But the truth of the matter is there's a lot of stuff that happens in our public airways. And a lot of that has to do with aircraft. Now, if you're flying a UAV, a drone at low altitudes, chances are there's never going to be a problem. But we have to know, because oftentimes there are people on board those planes. And it's not just other drones, and it's not just a problem with somebody being upset that a drone is in the air where it shouldn't be, or they feel like their privacy is not being protected. There's a lot going on right now with the development of this technology, and there has to be one entity that is keeping track of things for safety, for compliance, for penalty, and for other reasons to make sure that the airways are safe, that we can continue to use drones and investigate the technology for the benefit of all of us, and to use it to the furthest extent possible. So the FAA is that entity in the United States. There are other entities in other countries that a drone operator would have to be familiar with. Sorry about that. I had to take a drink. So Part 107 is a license to learn, really, as far as the FAA is concerned. I've dealt with a lot of pilots that want to fly drones and they want to fly commercially, whether it's to take video of real estate in their area and they want to make a little bit of side money, or they're providing maps for a company, or they're doing survey work with a licensed surveyor involved. A Part 107 license is the first step to going down that path. And it's a little complicated, but if you align yourself with somebody who's already done it once or several times or helped other people go through it, it's a pretty straightforward process. I think the difficulty of the Part 107 license is it's very difficult for the FAA to test people on whether or not they're able to stay aware and capable of knowing the regulations that the FAA sets down. And in order to test for that, oftentimes they have tricky questions. It's more about learning how to answer the question than it is about knowing how to fly a drone. And as far as that is concerned, you've got the written test, but you don't have a practical test. So I could take somebody and get them through the Part 107 license by enabling them to sit down, take the exam, and pass with 70% or more. It's a pass-fail test, and you can go back and take it again and again if you need to, but there's a cost involved. I think it's $160 to sit for the test. If you pass that test, then you definitely have a license, a Part 107, and you can go out and fly a drone commercially. But that in no way prepares somebody who is unfamiliar with aviation, the FAA regulations, or how to physically fly a drone to go out and be successful at business, videoing a project, or providing an accurate map of an area. That takes quite a bit more skill and some practical application to flying a drone and making sure that you're not trimming everybody's trees as you do it. The FAA is mostly concerned with property and personal safety, and so they lay out a lot of those questions during the course. But if anybody's interested in going down that path of getting your Part 107, please get in touch with me through Johnny later, and I'd be happy to help you with that process and show you where you can get more information. So just the bullet points here. And I try to be a little funny here. This has to do with commercial flights, FAA waivers. So there's a lot of regulations that say what you can't do. You can't fly over people. You typically cannot fly at night. You typically cannot fly beyond line of sight. So you've always got to have your drone in sight. A lot of these regulations are changing, and they'll probably change pretty quickly. Revocations happen when you're a Part 107 pilot. If you do something that you're not supposed to do, the FAA can take your license and you won't be allowed to do that again. Tree trimming is here, and I will tell you from personal experience, I plan my flights over and over and over again to make sure that everything's going to be safe, and yet I still come in contact with trees and other obstacles from time to time. You have drones that are trying to escape. They're mostly controlled in a grid map flight. They're mostly controlled by GPS location. And so if they lose track of the GPS or something goes wrong with their flight telemetry, they can fly off away from you. And if you're fortunate and you're prepared for such a thing, you can gain control of the UAV and bring it back. If not, oftentimes you switch over to a video representation of what the drone is seeing to try to figure out where it is when it finally goes down. And if none of those are true, then you might get lucky and look at telemetry from the controller and try to locate that UAV. I've never lost one completely, but I've certainly have lost control of one before. It was momentary, but it is exciting, and it creates a danger for people and for property. So it can be a very serious thing. And even though they're small craft, they're capable of doing a lot of damage in the wrong situation. So I like to remind people about that. Okay, why are drones becoming services that are essential? Well, they're introducing to people and to projects new information that they've never seen before. There's typically a cost savings, but it depends on what you're using it for and how big the project is. We can take a lot of this data and we can put it into artificial intelligence to run some queries on and find out new information about things that we were never able to do before. Let me give you an example. When our company, Mott MacDonald, goes out and it is locating pipelines and it's trying to get a really good handle on a right-of-way for a pipeline, they might go out and they might take, let's say, 200 GPS shots in an area around the station. These shots are extremely accurate. It takes a lot of time to set up a control source and make sure that your rod man is taking the points correctly. And typically it takes 2 people on the ground at a minimum. It usually takes about a day. So you're going to come back with 200 very accurate points. When I fly that same area with a UAV, I'm going to produce what's called a point cloud, and I will bring back, someplace in the neighborhood of 500 million points of accurate data. Now, that's accomplished through triangulation, through the law of large numbers where we're doing triangulation, and it is made even more accurate by a few ground control points that are set by those ground survey crew. They'll take a couple of shots on some targets for me. So you can see that we've got a lot more return for the same amount of time and typically approximately the same amount of money. There is a lot of back and forth that's going on these days with this new technology. So you've got survey crews that go out and they know how to do a certain function there in the field. They know that their product is very accurate and they know how to deal with that product when it comes back to the office. They can quickly turn that into a CAD drawing or a type of tin or surface so that civil can start working in CAD and their other applications. They don't have to worry so much about vegetation on the ground because when they take their shots, they're typically taking a shot of the ground. They're not taking a shot of the top of a bush. And for UAVs, we end up with pictures of bushes. Let me bring up something that might represent that very well. Yeah, here we go. Johnny, I'm going to ask you again if you can see my screen. I've switched again.
Yes, I can.
Okay. So this is a representation of a mining operation. And obviously they want to know specifics about the earth and where it is here. But I chose this picture because you can see this stubbly area over here. This is vegetation growth. And so if I bring back this point cloud back to survey and somebody wants to create a surface model out of it, they're going to have to do a couple of things first. You see the different colors here. The colors represent the either the intensity or the elevation of the points that were taken. And based on elevation, intensity, and many other things, there are algorithms that we can run on this point cloud that will basically erase all of the points that look like vegetation, and it will leave us with something that looks like, let's see if I've got this picture here. It'll leave us with something like the left-hand side here, which shows us the elevation, as opposed to all of the different pieces, parts of earth and roads and buildings and everything else. So there's quite a bit of work that has to be done to get to the same type of product that survey would put out. So we need to take that into consideration. I'll switch back to my just my presentation. Minimal equipment that's needed for a UAV program is the drone, and you'll consider what flight type and what flight length. There's quadcopters, there's fixed wing, there's several different types of aerial drones that you can use. The sensors, again, the LiDAR, you've got RGB, which is typically, it's just a photograph. You've got heat sensors, which obviously detect heat, and infrared sensors. You've got to consider insurance, desktop planning for your flight, field execution for the flight, telemetry and compliance. A lot of companies require us to monitor all of our battery cycles and how we're using our drones, whether or not the batteries are being kept up properly. So we get trying to bring over. Yeah, there we go. So we try to watch the cell voltages on all of our batteries. We've got to track that for different clients. We look at weather is another obstacle and example of some of the things that we need to take into consideration. I think I'm starting to run out of time here, so I don't want to bog this down, but there have been great examples of being able to get information without being on the ground, where we fly over an area. For instance, had to get some survey over an interstate at one point, and it was during the end of hurricane season. We had a storm that it would have been dangerous to have a regular flight up in the air, but fortunately the clouds were above the level that I was going to be able to fly, and we were able to get good drone coverage from that. Oh, gone. Here we go. Okay. We have different challenges. The technology is still unknown. I talked about weather. I talked about airspace. Line of sight, you always got to be able to see the UAV. File size transfers. This produces a lot of data, so you've got to be able to what's called decimate the data, the point cloud, to a level that programs can use inside of companies. Magnetic barriers are a really big deal because you're dealing with drones that use their compasses and use their GPS locations. And if you're flying around huge natural gas transmission lines, which are buried in the ground, oftentimes those create some sort of magnetic barrier, and it leads to drones that often fly off course, and you've got to reset the flight and start over again. There are a lot of different steps that you can go through to build your own UAV service, or if you want to start off and you want to offer that alone, not inside your company, but outside your company, there are options to do it. But hopefully I've shown you some of the details that say, hey, there's a lot more than just launching a drone and having it up in the air and bringing back good information. I'm trying to bring up a video now, so hold on with me, please. Well, that's not working. Sorry, folks. This is an example I wanted to show of a flight. Another slip. Not going to say exactly who this was for, but it's a great representation of what we get into. The terrain in this area was a difference of 1,100 feet. So we started on the top of this mountain where you can actually see the trucks. This comes into better and better resolution as it loads up the information. We wanted to show how this mountainous area had a slip. And as we moved down across what had been repaired in this slip, we get down to 1,100 feet below our original flight pattern. And you can see the detail, sometimes too much. You can see the detail of the rocks and the coverage of a creek bed down at the bottom. So we get enough information to show to project management and also for using for some of our products that we turn over to the client. This ends up being in profile and line drawings, really high resolution image of the area that we're working on. So Johnny, I think we're coming up to the end of our time. Am I mistaken about that?
Yeah, we're about there. Do we want to take some questions at this time?
Yeah, that'd be great. Thank you.
If you got a question, you can unmute your mic and go ahead and ask. Well, while people think about it, I got a question for you, Jim, on the railroad scenario that you were talking about. Did you technically need permission from the railroad to fly that mission?
We did not technically need permission to fly it. I could not find any regulation that said there was control by the railroad in the airspace, and it was not controlled airspace. But we sought that anyway. The railroad knew we were trying to get the survey done, and they know that they've got their own bureaucracy and process that they need to go through. So they were quite happy that we found an opportunity to get the survey done, to finish the project, and to not bog them down with the process inside.
Jim,
That's a good
this is
question,
David
John.
Marks. Jim,
Hi,
this is
David.
David Marks. I'm curious about the competition for the drone companies. Is the field saturated? Is it growing? Is it not enough? Do you need employees? In the big picture in our region.
That's a great question, and it's a question that I ask myself almost daily. I don't think, I know I don't have an answer to your question, David, but I'll tell you what I've experienced. The lower end of the UAV services, so for real estate, for video footage of homes and things like that, I think that there is quite a saturation of Part 107 pilots. There are even companies that have built themselves around the idea that they will farm out to pilots that are registered with them any job that comes in to focus in a particular area. So they've mapped out where the Part 107 pilots are. If they get a job request for that area, they'll send it out to several different pilots, and whoever responds at the best rate gets the job. I think that I'm separated quite a bit just because of my background in manned flight, my familiarity with the FAA, and my experience with professional drones in both survey, inspection, all of those different areas. I think that keeps me in a different realm, and it's not saturated. I perform most of these services through Mott MacDonald, and Mott MacDonald needs those services to come back to them internally. So there's not a whole lot of competition in that regard. But for my company, Ground Scouts, there has been a lot of competition. But the competition isn't because somebody else can do it better or they can do it more cheaply. It's because a lot of companies that started offering drone solutions have already established formal relationships with the larger companies like the TransCanadas, the Dominions, and all the other companies that would seek those services. So the barrier to entry is definitely there. And the barrier to entry is, do you have a working relationship with either people who will request specifically your service, or you've got an MSA in place that you can do those services for them?
Thank you, Jim.
Yeah. Anybody else?
Yeah, Jim, this is Michael Lopez.
Hi, Michael.
I wanted to just point out that a couple of things. Getting Series 107 license is not a joke. I mean, it's the same governmental regulated company that regulates a Boeing 757 Airbus is got their fingers in drone flight. And we've all seen medical, evac helicopters flying to a hospital at very low altitudes. And so they're the importance of what they do is so that some 15-year-old kid's not flying a drone in the flight path of a helicopter. So there's flight altitude limits that we are regulated at to fly a drone. Correct?
Thank you, Michael. I'm sorry if you got the impression that I was joking about that.
No,
But
not at all. Not at all.
in response to the point that you're making, it is very serious. It is also huge. It's huge to regulate the industry of aviation, and this is a subsection of it. My background in aviation is quite long term. My brother is a captain with JetBlue. My father is a representative of the FAA. I have dealt directly with the FAA in, things that people don't even think about. It comes into the pie-shaped area of what we don't know. So unless you have a Part 107 license and you become familiar with some of the things that the FAA is really concerned with, and you continue to do your continuing education, there are many things that you wouldn't even know that you're outside the boundary of the FAA regulations or why they're even there. And I like to keep that kind of airy, especially for this group of people who are probably not familiar with drones and the regulations and the FAA. I don't want to scare people off because this is a great technology that is going to find its place over a period of years, but it can be very scary if you just take it from the perspective of the FAA regulations. For instance, anybody can go out and buy a prosumer drone, hack through some of the protections, especially if it's a DJI made in China drone, and they can fly that sucker up to thousands of feet in the air. And that would create a lot of potential safety issues for manned flight and other flight. And there's nothing except for regulations and knowledge that would keep a person from doing that. When you go through the Part 107 system, it's not a joke, but there's the information and the breadth of situations is so big. There is no way to test for that sort of thing. And so the FAA is left, and partly because of their bureaucracy too, they're left in the same kind of situation they're in with manned flight. I'm an instrument-rated manned pilot, and so I've had to go through a lot of exams, both oral, practical, and written, and I've gone through the courseware of the FAA. And I think I can make both points at the same time. The first point is it is a very serious thing because it presents a clear and present danger to people. We've already seen that, not just in fines, but in accidents and reactions to manned flights where a drone was involved. But I can also point to the less regulated side and say, look, drones are here to stay one way or another. We've got to find a way to deal with them safely and produce good things from them. And so if you're interested, the first step is the Part 107. But get in touch with somebody who's familiar with the Part 107 and actually is flying drones, because there is so much more than that Part 107 courseware would take you through. So thank you, Michael, for pointing that out. And again, I'm sorry if anybody got the impression that I was just sliding away from the seriousness of the FAA and the regulations that are put in place. I'm not. It is just an enormous task to be aware of the things that are out there. And I've been doing this for years with plenty of inside knowledge as to what the FAA is trying to do and what they have done and what they will do. And I still find myself having to go back to the regulations to find out what it actually says when I'm going to do a flight.
Hey, Jim, I want to make one more point.
Sure. Thank you.
With regard, if you don't mind, with regard to the LiDAR, laser imaging laser imaging detection and ranging
Uh-huh.
is the acronym. So we've
I
all
have
done,
heard others. Yes.
we've all done like Google mapping desktop surveying, where we try to map out a route with a right-of-way or something. And my experience has been that sometimes that Google mapping can be up to 300 feet off of a line point.
That's correct.
The LiDAR imagery and 3D detection gives you up to like within centimeters of distances. So like surveying becomes so much more accurate with drone and LiDAR imagery than Google mapping.
Absolutely. It can. Be aware that the accuracy that comes back from any of these sensors goes through a lot of processing, and it takes people who are using the tools properly and correcting for differences before you get those levels of accuracy. And that's one of the reasons that whenever we're doing local accuracy as opposed to geo accuracy, you're probably needing to have a licensed surveyor that is involved in that process, especially if you're looking for a geolocation in particular, because there's a lot to the process. It can bring you back a point cloud where you can look at the point cloud and see two different objects in the point cloud, say, for instance, the distance of a boat dock away from the shore. And in that situation of the point cloud, you would have a tremendous accuracy, probably down to the centimeter, depending on how high you would fly, LiDAR or photogrammetry. But if you are looking for accuracy from a geolocation perspective, like where exactly on the Earth is that point, you start dealing with different datum references that become an important part of correcting that LiDAR point cloud or that photogrammetry point cloud, where you can have accuracies that skew quite a bit. A great example is this latest slip that we did with photogrammetry. We found that there were inaccuracies of up to 5 feet only in elevation. So we had an XY that was within sub-centimeter, but we had elevation that was off at both ends of the flight in the corridor. And we hadn't rectified that completely to find out where the error is, but it does come up, and it takes experienced people and good tools to make sure that you end up with that fine product. But in general, Michael, you're absolutely right. When we're flying with a LiDAR sensor, we would expect to have sub-centimeter accuracy, much, much, much better than what you would typically get from a survey crew out on the ground.
Appreciate that. Thank you.
All right. Do we have any additional questions for Jim today? All righty. Well, we'd like to thank Jim for hopefully being our last virtual speaker as we're moving back to face-to-face here in June. So our next event will be a joint venture, a joint meeting with NAILA. And the topic for June, which will be June 15th, will be contracting with special groups. And our speaker will be Renee Anderson. We'll get the registration out. The registration is going to be a little different than normal, as NAILA is going to go ahead and take care of the registration and the payment through their system. And then we'll be going, and that'll be the third Tuesday of the month due to the IRWA's educational conference is the same time as we would normally meet, which is the second Tuesday. Once again, we appreciate everybody's support of the group. Now that we're a chapter, this journey has just begun, and we're looking for more input from other people, and also a little bit of a call for speakers. We've got speakers. We've got availability right now for the rest of the year for September, October, and December. So if anybody has a topic or somebody would like to present a topic, please let me know, and we can get you scheduled and get everything worked out. So we'll be getting today's video up on YouTube later tonight, and then we'll be sending out the link with everybody in attendance, their contact information in a spreadsheet. So if you want to add them to your address book, if you want to reach out to somebody on the call, you have that ability. And part of this group is education and relationship building, and I encourage everybody to network with others, make connections on LinkedIn, and we look forward to hopefully seeing you in June face to face. So thank you guys very much, and you have a great day.
Thanks, Johnny.
Thank you, Jim. Thank you, Johnny.
Thanks, Jim and Johnny. Thank you very much.